Hello, my name is Brian.
I'm Megan.
I'm Jameer.
I'm Tashwan.
And I'm Christopher. And here we're Group 5, and we're here to talk about vectors.
We're all familiar with a two-dimensional Cartesian plane. However, in physics, we need to use all three dimensions. Here you can see a three-dimensional Cartesian plane with an added z-axis. In order to draw a three-dimensional Cartesian plane, the z-axis goes up, the y-axis goes to the right, and the x-axis comes down and to the left. When plotting points in three dimensions, you start with the x value, the y value, and then the z value. So if we were plotting A, we'd come along the x-axis 2 units, along the y-axis 1 unit, and up 3 units on the z-axis. And there's A. To plot B, you do the same thing. So you'd come down 1, over 2, and up 1. And in order to draw vector A, you draw a line or an arrow from point A to point B, and that's vector A.
So we use the polar coordinate system to find the direction and magnitude of vectors. So in this case, our vector is labeled vector r, and you can find the magnitude by using the Pythagorean theorem. So we have 4 and 3 for x and y. So this would be like saying vector r squared equals x squared and y squared. So if you take the square root of that, it would be 5. And so that would be the magnitude of vector r. So then to find the angle of vector r, you can use regular trigonometry, cosine theta, sine theta, and tan theta.
Hi guys, this is how you add vectors. So we were given 3 vectors, A, B, and C. So they start at the origin, and you take A, and you add B to the tip of A, and then you add C to the tip of B, and that's where you would end. So you go from the origin to the end to find the displacement. The displacement should be adding vectors, and that's your resultant R, 4 and 4.
So this is how you subtract vectors. We have vectors A and vector B, and you graph them in the same points. And the resulting vector is graphed on the endpoints, and you end up with vector A plus negative vector B.
The displacement is 0 because it went back to its original spot. The displacement is the distance between me and her because she's where it started and I'm where it ended.
This is what just happened outside, and this is where the camera was. Now, she threw it to him, he threw it to him, he threw it to him, and he threw it to me. So, this is vector A, this is vector B, C, and D. And this is the resultant vector, which is also the displacement.
When adding vectors, you can break them into their x and y components to make adding them together easier. So if you look at vector A, it goes up on the y-axis 3, doesn't go on the x-axis. B goes 2 on the x-axis and not on the y-axis. And then the last 2 go down 1.5 and down 2. Now if you add all the x components up, you get 2, and if you add all the y components up, you get negative 1/2. And these are the components of the resultant displacement vector.
So these are the components that Brian just found, and we can use them to find the magnitude of the resultant vector. So you can set it up as a triangle with negative 1/2 in the y direction and 2 in the x direction. So using the Pythagorean theorem, you can do 2 squared plus 0.5 squared and take the square root to get the square root of 4.25. And then to find the angle of the resultant vector, you can do the inverse tangent of negative 1/2 over 2 to get 24.5 degrees below the x-axis.
What's up, guys? I hope you guys learned a lot today, because I did. Did you guys have fun?
Yeah, it was
Yeah.
great.
Yeah, great.